Good morning, UK. Good evening, Australia, and welcome to our first ITS Squared webinar brought to you by ITS Australia and ITS UK. I'm Paul Hutton here in London to host today's event where we'll be talking about smart motorways, their implementation in both countries, their similarities and differences. We have three guests to talk this through today. Paul Glover, who's Technical Director of ITS at GHD, Stephen Bayliss, Partner at Lime Solicitors, and Alex Torday, Global Head of Professional Services at Aimsun. Before we start though, let's get a quick word from the CEO of ITS Australia, Susan Harris. The wonders of webinars mean Susan, despite being 12,000 miles away from where I am, and I can host this event together. So Susan, thank you for this great initiative between ITS UK and ITS Australia.
Oh, thanks so much, Paul. What a delight it is to be kicking off this this new series. I'm really thrilled to be partnering with yourself, Paul, and Jenny Martin and ITS UK to deliver this new series. And just looking through the participants list, it's fantastic to see some really familiar names and people that we've been working through at World Congresses and other events across the UK and across Europe. And thanks so much for dialing into this session. So there are some really great initiatives being delivered in Australia and in the UK, and I'm thrilled to be able to bring them here to you today and in this series. I think a particular note at the moment is in Australia, we're experiencing record levels of investment in delivery of transport infrastructure. So this is across rail and road projects, a combination of existing major projects and initiatives, plus, of course, an extra layer of stimulus-related initiatives that have been announced over the last, 3 to 6 months. So we're working hard with our members to make sure that this new infrastructure that's being delivered is smart infrastructure. And we're really pleased to be able to bring this series where we're really talking about how that's happening and some of the initiatives that are being delivered. And looking forward, Paul, to hearing a bit more from some of our members and your members today about the proud history that both Australia and the UK have in delivering smart motorway technologies across our major cities. Thanks very much, Paul.
So thank you very much indeed, Susan, for that. And thank you to the teams of ITS Australia and ITS UK for making this happen. So smart motorways, I went to that font of all knowledge Wikipedia to look up the definition that it gave. And it said a smart motorway is defined as being a section of motorway that uses active travel management techniques to increase capacity by use of variable speed limits and hard shoulder running. Smart motorways are mainly found in Great Britain, it says, although we should really say England in that case, although the concept is also becoming common in Australia, New Zealand and some parts of Switzerland. So there are smart motorways both here in England and in Australia, but what are the similarities and differences? We'll have discussion about them once we've heard from our three speakers, and you can put your questions in the chat box and we'll come to those in due course. Now, our first guest is Paul Glover, who's got more than 35 years experience managing strategic partnerships, ITS programs and major transport technology projects across the United Kingdom, Europe, Middle East and Australia. His experience in smart motorways goes way back to the mid-2000s in the UK, where he was involved as a consultant on the first operational smart motorway in the UK. He designed more than 450 kilometres of smart expressways in the state of Qatar and was the technical design authority for Main Roads Western Australia, and currently leads GHD's smart transport work, focusing on the intelligent use of technology for Australia's road networks. So he's not really a bad person to start with when we talk about smart motorways in the two countries and telling us the similarities and differences. So Paul, thank you for joining us. Give us a brief overview of smart motorways, please.
Obviously, Paul, you've covered off what we're talking about today, so we can go to the next slide now. I thought it was useful with putting some context into smart freeways, actually just sort of contextualize the differences between the two countries as well, although they seem to be sort of similar. There's a lot of change, a lot of differences in the context of the countries, and as you can see on the right-hand side of Australia, we've got states and territories, and each of those states and territories is responsible for its own area, so it has its own its own legislation and its own standards and specifications. So that causes a few issues in design. And we're working with ITS Australia and Ausroads trying to improve that situation on the standards side. But there's no federal body like the Highways England or whatever it's called these days. It changes every week. So there's no federal overview that mandates all of this. So there is a difference in each of those states of how it's been applied and implemented and indeed operated. But to give you an idea, if we go to the next slide, that's the size of the UK superimposed over Australia. So, you know, there is a lot of issues in terms of size, and that means in Australia there's an awful lot of movement by road. The rail network doesn't really support a lot of the movement of freight as well. So there's a lot of movement of freight on that road network as well. So there has been a drive to actually maximise the utility out of the road network, as in the UK, because construction is limited in some areas, and that's led to a number of different schemes being put in different jurisdictions and states. And I'll come on to the latest one that I was involved with later in this presentation. But to go to the next slide, as Paul was talking about, which was about the history and terminology. This is slightly different because obviously controlled motorways are the same as managed motorways in some contexts, but the terminology has been used in Australia around managed motorways. But smart motorways now cover those three at the bottom, which are the dynamic hard shoulder running, the all-lane running, and then what I call non-all-lane running, which is the controlled motorway or managed motorways, which are where we have, you know, more than 3 lanes and hard shoulder, and the use of the lane use management system and variable speed limits. So you can see immediately that there's a lot of synergy between what goes on in the UK and what's happened in Australia. And a number of schemes have been implemented in Australia, similar to learning from the UK, and I guess vice versa a little bit. I think it's probably come more this way, but the Monash Freeway was 2007. So I think controlled motorways have been in since 1995 on the M25. And then we had the dynamic hard shoulder in 2007, something like that. Some people on the call, I can see a lot of people from ex-Mouchal colleagues. And then the all-lane running on the M25, M1 more recently in the UK. So there's a lot of synergies there. If you go to the next slide, other synergies that we have in the context of smart motorways are that they all have other things in common, and 3 things I always look at in terms of the people. There's always operators and people out on the network. We'll come on to some of those definitions in the next slide, but we have processes and protocols and getting the standard operating procedures right for general congestion management, traffic management, and then incident management. And then there's different technologies and a range of technologies that are used to enable the safe, effective, and efficient operation of the smart motorway, smart freeway, smart expressway, whatever you call that. So if you have a look at the next slide. So I'm just citing an example here from Main Roads and reference them in WA at the bottom. It was a scheme that I was involved with while working for Main Roads from the design perspective and through the implementation, planning and transition into operations. So it's the latest and probably the latest and greatest use of the technology in Australia. It opened middle of last year. And on the right-hand side, you can see that there's an inset in the diagram which shows ramp metering at 5 intersections. And then the diagram in the middle, which shows the area north of Canning Highway to the Narrows Bridge, which is geospatially constrained area, which has got obviously the foreshore on the left-hand side, the freeway corridor, which has a rail corridor running through the median. So very constrained, and you can see is the vertical alignment is pretty flat, but the horizontal alignment doesn't really do it justice there. It's quite wiggly, like a bit like a snake, a serpent. So some very challenging engineering solutions required. And on the left-hand side, you can see how the numbers of devices stacked up to enable the safe operation of the smart freeway there. So if we go to the next slide, please. So carrying on the theme of similarities, I've listed the technologies down the left-hand side. We are ITS, so we are allowed to use a lot of acronyms. But you can see a lot of synergy. It doesn't quite line up there, but there's a lot of synergies between the approaches taken. On the left-hand side with the UK, the GAP is supposed to be aligned with the HERO algorithm, the coordinated ramp signals on the left-hand side. And then on the right-hand side with Australia, there's currently in that scheme and in most other jurisdictions, there is currently no enforcement systems on these. So we have the software and hardware, the OMCSs, the control systems. We have the vehicle detection systems and various types used those. And so just coming back to the OMCS, the majority of the systems in Australia use a stream system with the local jurisdictions, and there are private motorways as well, but not really smart motorways as you'd call them. And then we have the lane use management system with the variable speed limits. We have the 2 algorithms running and the A-linear algorithm running, which runs the main line in the UK as well. CCTV, ramp metering, and stop vehicle detection. And the scheme that I was involved with put in 2 types of stop vehicle detection. The main line using the radar system from Navtec, and the use of FLIR thermal imaging cameras in the emergency stopping bays, which are also facilitated with help phones. And they are roughly around 650 meter spacing on that part of the network. And we're currently looking at designs for, we've got 5 other designs for other sections of the Kwinana and Mitchell freeways we're undertaking for main roads at the moment. And 3 of those are looking at all lane running sections to follow on from the experience that main roads have had with this. And then at the bottom there, we have IRS, which is the Instant Response Service, which is not quite what the HATOs, or if they're still called HATOs in the UK, but it's a dedicated service to provide recovery facilities, safety services on that section of all lane running. Really, that sort of just concludes the sort of shared learnings, and I guess we'll come on to how some of these technologies are enabling Department for Transport, Highways England to respond to the current situation in the UK, which I think we're going to hear more of from the next speaker. Thank you.
Thank you very much indeed, Paul. We'll hear more from Paul in a moment. And as he alluded to there, if you're watching in the UK, you'll know the all-lane running aspect of smart motorways has become controversial. But for our Australian participants, let me explain that the issue is over not having a hard shoulder, which has seen some high-profile news stories about people being killed while in a running lane that used to be a hard shoulder. So much so that recently a coroner called for a review of them, and a police chief actually wrote asking for them to be abandoned before, and I quote, more lives are lost. But what is the legal aspect around delivering ensuring safety on our highways, and what does it mean for technological implementation? Stephen Bayliss is a partner with Lime Solicitors, specialising in serious and catastrophic injuries. He qualified at De Montfort University in the UK and is a senior litigator member of the Association of Personal Injury Lawyers. Stephen was in fact the first lawyer in the country to obtain Headway's certificate in brain injury studies. So he's going to now look at the legal aspects. Of course, we've got different legal jurisdictions, obviously, in the UK and Australia, but based on very similar principles. So I think what we're talking about here, we can learn from in both the UK and Australia. But for the moment, Stephen, sir, the floor is yours.
Hello, good morning, good evening, everyone. My background, just quickly, I'm a personal injury litigator by trade. So the criminal elements that are creeping into comments from coroners and police chiefs recently are not something I would normally get involved with. If we were approached by families who've unfortunately lost loved ones, we'd be looking to bring claims against the other motorists that have actually directly caused the accident. But just as a way I would approach it, now I think Highways England and the Transport Secretary will have to look at this. We go back to 2006 when smart motorways were introduced in the well, primarily in England, and the aim was to sort of improve traffic flow without additional costs and environmental impact of widening motorways. Highways England, when you look at the stats they've produced, have pointed to a 22% improvement in journey reliability, and personal injury claims have reduced by half. But as Paul has just touched on, there's a lot of media exposure to the use and continuing use of smart motorways in this country and jurisdiction. Primarily, it relates to an incident from 2019 in which I think 2 individuals unfortunately lost their lives. So in terms of the introduction, it's fairly obvious. It was use of technology and smart motorways to improve traffic flow, reduce pollution, and improve journey reliability. I'm not the expert on the acronyms, but obviously from our perspective, there's been a variety of new zones introduced with hard shoulders either being lost permanently or a sort of on and off basis. Rossborough have reduced or indicated there's been a reduction in accidents. This was relating to 2 stretches of the M25, and over a 3 or 4 year period, it went down from something like 13 accidents per million miles to 9. So everything looks good and points to an improvement, but clearly all was not well, and a review was recommended, and the results of that were published by the Transport Minister in March of last year. Obviously, events a few weeks after that have overtaken everyone, unfortunately, but the upshot of that report was to abolish the use of dynamic hard shoulders, speed up the deployment of stock vehicle deployment technology. And I think this is one of the issues that's raised in this recent case, and I'll touch on that shortly. A reduction in the distance between emergency stop areas, make them more visible, and then display of obstruction to the road messages. Now, as you'll come on to this, there seems to be a long gap between incidents happening and that being deployed. So I think that's one of the big areas that I think Highways England and the Transport Secretary will have to focus on. In terms of the against them, the review obviously highlighted problems, and the information from, it was probably early last year, March last year, points to 38 deaths on smart motorways in the preceding 5 years. Now, the average of unfortunate fatalities on the motorway network is averaging just over 100. It had been coming down in recent years, but sort of has been static for sort of, I think, about 4 or 5 years now at just over 100. So give or take the maths, so that means the smart motorways are contributing to getting on for 8% of motorway fatalities. I couldn't find out, unfortunately, how much by way of percentage smart motorways make of the overall network. But one would assume it's a lot less than 8%. So despite the figures pointing to an improvement in road safety and reduction in accidents, it may well be, if the incidents are analysed more fully and the percentages looked at, they do seem to be contributing to a higher incidence of fatal accidents. I've not got any statistics on sort of serious accidents with life-changing injuries, but that would seem to pose problems for Highways England, that they do now need to look at what's been done and what's taken place over the last year since the outcome of that review. And as touched upon, the coroner in the recent case, this was just from January last year, made quite a stark comment about these smart motorways carrying an ongoing risk of future deaths. So that's fairly bleak terms to use. And obviously the coroner was privy to all the information in relation to this incident, and I've been able to glean some of it, which I'll come on to shortly. So you would hope those comments aren't made lightly. And as going on to the next slide, obviously the South Yorkshire Police and Crime Commissioner has written an open letter to the Secretary of State for Transport. What I found out about this particular accident, minor rear end shunt, and the drivers were exchanging details and struck by a lorry some 16 minutes and 21 seconds afterwards. Now, I'm assuming the incident must have happened in the first lane, which conventionally would have been a hard shoulder, but as often, some of the specifics are lost when reporting takes place. Now, that seems an awful long time. Now, whether driver education is something that should be looked at, my personal view, if I've been involved in an accident and it was even on a conventional hard shoulder, I think the guidance is that you remove yourself from the scene, get over the barriers, and if you can, and if that involves scrabbling down a verge or whatever, to do that. So I'm not sure of the specifics and whether that was possible at this part of the network, but that's possibly something that would need addressing. Likewise, the AA publications as to time elapsed from an incident to the signage notifying drivers of 17 minutes and 1 second does seem alarmingly high. Panorama made a Freedom of Information request to Highways England that points to a 20-fold increase in near misses on one particular section of the M25. So there does seem a number of problems that require greater analysis. I think any next review that's published will have to look at the improvements that have been made since the 2019 accident that may sort of seek to reduce the urgency of any future steps. But yet, overall, it would appear on the face of it that fatalities on smart motorways make a significant percentage of fatalities. I don't know about other accidents, and again, that's possibly something that Highways England need to be looking at. It would seem clear that the presence of a conventional hard shoulder, at least in this incident in question, would have avoided the fatality. They're not in my slides, but I'm sure I've seen somewhere Highways England have said that even on conventional motorways, 1 in 12 fatalities occurs on a hard shoulder. So there are clearly safety issues and concerns that need looking at. The upshot of the recent case is that the widow has indicated that the Highways England or some of the senior people should be looked at from a corporate manslaughter point of view. Now, this isn't my expertise, and there's no point me suggesting what the Crown Prosecution Service may or may not do. I personally think that on the basis Highways England have made a positive choice to continue with the use of smart motorways, there would be exemptions available to argue that it was public policy and an allocation of public resources. So I suspect, whilst it's always sad when someone loses their lives, and it's right that there's emotion there, I'm not sure this particular element will have any traction. That said, government organisations can be prosecuted. So those within Highways England rightly will be able to look at this very carefully. I've come up with a what next. Obviously I'm not a motorways expert, and it may well be since 2019 that there has been greater use of technology to identify when incidents have taken place and a road is closed. But there's clearly an issue. There seems to be a disproportionate number of fatalities. I say from a litigator's point of view, we would be looking at the lorry driver as being primarily responsible. But that said, Highways England have a duty that whatever they do implement should be at least as safe, if not safer, than what was there before. Now, if it may well be the overall reduction in accidents is there, traffic movement has improved, but if as a consequence fatalities have increased, then yeah, they will have to be looking at this very closely, very quickly, and either indicating that steps since 2019 have sought to limit the problems, or what can be done to improve the technology. I've put in some other comments. The environmental consequences of congestion on our roads is a factor. There was another coroner comment from a recent case where a young girl unfortunately suffered fatal respiratory problems that the coroner held were linked to pollution. So it isn't just as simple as saying we're going to turn off the smart motorways, in my view. But I do think the safety element of these specific stretches of motorway, which may be intrinsically unsafe historically, I don't know, but that needs looking at, in my view, very carefully. So that's it from my legal point of view. So hopefully that was useful. And any questions? Okay.
Thank you very much, Stephen. And the interesting thing is when you have panelists, attendees who have expertise, numbers have been coming in on the chat while you were speaking that it's around about 20% of the network is smart motorway now. So as the statistics come through, we will get a much better idea of the comparison between the two. And whenever I'm interviewed about smart motorways, which happens quite often, I always point out exactly what you said, which is that hard shoulders themselves are far from safe places to be. And one of the things we'll come on to in our chat in a few minutes' time is about the fact that there seems now almost to be a belief that the hard shoulder is this safe haven, and not having the hard shoulder is extremely dangerous. And if only we had a hard shoulder, we'd all be so safe. And actually, the reality doesn't really stack up with that. But for now, Stephen, we'll come back to questions from you in a moment. But what can we do to improve safety on the roads and to train staff to help them respond to incidents? ITS Australia and ITS UK member Aimson has been doing a lot of work on this front using its transport modelling. So let's hear from Alex Torday in Sydney, who's Global Head of Professional Services for Aimson and was previously MD of Aimson Australia. And he's been working with his team on this solution. So Alex, thank you for joining us. Explain what you've been doing, please.
Thanks, Paul. Good morning and good evening, everyone. First, thank you for ITS Australia and ITS UK for allowing me to join this very interesting session. So the presentation on my side will be more a little bit more on the technical side, and is about discussing about how transport modeling can help at the different stages of the development and the operation of a smart motorway. So I'm just trying to move to the next slide. Perfect. So modeling can embrace a lot of different things. So basically, let me start by explaining what I'm meaning by modeling. So we have definitely the needs for transport simulation. We hear a lot of discussions about models, big data, digital twins, machine learning, making very good use of every time we have more and more data available out there about the transportation. Data analytics that will basically name all these different techniques are extremely important, necessary. They are improving a lot of our understanding of transport. and we do in our company do a lot of this data analytics and every time more. They are necessary but not sufficient for doing proper forecasting and assessments of transportation network. This is why we continue to rely very much onto simulation techniques. Simulation techniques in the opposition to analytics that will, for example, let you know that, well, I see that if it's 8 a.m., I see that most of people are turning left. And if it's 5 p.m., most of people are turning right, which is basically learning from the data and try to repeat patterns of things that you observe. What we're trying to have in simulation is to have behavioral models. What is important is to know why people turn left in the morning and why people turn right in the morning. The reasons why we are insisting that behavioral models are fundamental is to be able to answer questions, what we call the what if scenarios. What happens if this bridge gets closed for 2 hours? What happens if there is an incident? What happens if you have to evacuate a stadium during a concert, or all these things? So basically, a lot of these what if questions comes about things that potentially has never happened in the past. So you cannot really learn from past data. You have to understand why people behave so that you are able to correctly answer the question. So now coming to how this is helping smart motorways, there is different phases. And typically the one that most of the people will know is the use of transport simulation for the planning stage. So basically you want to plan a new smart motorway and you want to make decisions about, do I need 1 variable message sign, 10 variable message signs, 100 variable message signs? You want to balance what are the benefits compared to the cost of deployment, and especially the location of the different devices. Putting 10 variable message signs between 2 on-ramps doesn't make any sense. Do you need to put it after each on-ramps and off-ramps? So basically, the planning phase is about testing a lot of different scenarios, configurations, and to put in relation the cost of deploying these devices and this smart motorway in general, and the benefits that you expect from it in its future operation. Then the next one that I will give some example later a bit more in detail is the training phase. So as Paul was saying, there is always operators behind the smart motorways that are taking decisions. So the idea is, and we'll see the technicalities on the next slide, is basically to have a virtual world that is the simulation of the smart motorway and have the operators using their usual environment to take decisions and take action, but instead of doing it against the real world, they will do it against a simulated world. Now, the third one this time is not for training, but it's for the real daily operation. So this is what we call the real-time decision support. So real-time decision support is basically at any time you are looking in the near-term future, we're talking about 1 hour to maybe 3-4 hours ahead, about how the traffic on your smart motorway will behave based on the current knowledge of the conditions, or potentially some future events that will happen, like a road closure where you have to replace a pavement and you plan to do this at 5 a.m. But for whatever reason, suddenly there is a lot of traffic that is coming on the smart motorway because there was an accident on the arterials that was next to this smart motorway. So maybe you want to immediately cancel this road work this morning. You will not have done it yesterday. You will not do it the day after. The idea really here is to be able to integrate all the real-time components of what is happening on these smart motorways, and then have the operators ask the question about, what if I was doing this or doing that? What if I was asking the people to exit the motorway? What if I was decreasing the speed at this point? So basically, it helps the operators to compare different options of actions before taking these actions. So I have a couple of extra slides to develop a bit more this concept. So this is one project that I think Western Australia Main Roads has already mentioned this project in a previous presentation of ITS Australia. This is currently being tested and being used, so I'm not absolutely not presenting the results and how efficient it is. It's still too early. I'm just explaining for a better understanding the concept. So streams from Transmax will be the ITS platform, the tool that the operators will use to observe the status of the motorway and to take actions. So basically, in the real life, this will be connected to real devices in two directions. First, you will get vehicle detections or CCTV camera that is allowing you to get a vision of the status of your smart motorway. And then through your usual interface, that will be your interface for your daily work, you take actions. You change the status of a variable message signs, or you want to increase the ratio of or the capacity of a specific RAM metric. So the idea here is basically that the simulation will emulate the vehicle detections, feed these to the streams platform, and basically the operators will react to what they are observing and take actions, and then change the status of the devices in the simulation. And obviously the vehicles in the simulation will react to this change of status of the devices, and the operators will see the consequences of the action they have taken. And then you continue this circle. And I do remember Paul was mentioning the Kununurra Freeway. In fact, we started to develop this concept with Paul and all the team of Western Australia Main Roads. Now, the other concept, the decision support system, and this is courtesy of Tyco and Transport for New South Wales. This is a few pictures of the M4 smart motorway, in which we have been working with them to provide this decision support engine in the background of what is the tool that the operators will use. So in this case, this is Tyco's user interface, in which you are able to monitor the status of all your devices. You can see on the top right the different status of your LUM or your speed, your variable speed signs. On the left, you will enter an incident that just has happened on your motorway. You have all the details about the number of lanes that are closed, your estimates about the duration, about this incident. And then on the bottom right, what you see is the results of the prediction. If you do nothing, if you plan a very aggressive reaction to it, if you want to reroute people through some arterials, for example, or if you want to do nothing. I'm mentioning the do nothing because we have done a lot of projects in Europe, in North America. We have done what they call more integrated corridor management in North America. That is not too far from the smart motorway we're talking here. And the learning we have from using these decision support tools for the last 6-7 years is that in many cases, the do nothing is the best way. Sometimes operators try to overreact because they try on good faith to try to find a solution. And sometimes the situation or the network that is available, especially of arterials, doesn't allow you to do anything really to get the situation better. So basically, that's a bit of the idea about how simulation can support smart motorways. And I'm happy, obviously, to discuss more in detail later. But I'm pass over to Paul. Thank you.
Thank you very much indeed, Alex. That's fascinating and not the obvious solution that you would think of when you think of transport modelling. So really clever idea to start to use that for the training and the decision support in real time. Terrific stuff. If I could get our three panelists to all now switch their cameras on, please. The questions have been coming in, the comments have been coming in. Please do put them into the chat function on your Zoom screen and you can join in on that. But we have our guests together, and I think Paul, you've been listening to the controversies going on in the UK that Stephen was explaining when it comes to fears about safety. And it does seem, looking at the numbers, that perception and reality are different things. But is it almost a news agenda thing that deaths on roads happen so often that people don't bother reporting them anymore? You don't hear of them, yet a death on a smart motorway is a news story. So it's a kind of man bites dog versus dog bites man argument, that the smart motorway expectations are much higher than other motorways would be.
I think they're relatively new in the context of all-lane running in Australia, and thankfully there hasn't been, to my knowledge, a major incident, certainly not a fatality on the sections that I'm familiar with in Australia. The size matters issue is an interesting one with Australia as well, because there's only 25 million people in the whole of that area that we showed earlier. And the transport tends to be quite an active part of local news. Certainly where I live in New South Wales, every time there's an incident on the motorway with a truck catching fire or something happening, it's on the news and being talked about. So the context of it is slightly different, and it really relates around, I think, cultures of countries and their sort of interest in that subject. When we were in Qatar, for example, and we were designing the road network there, we were having to design to put in enforcement systems on the hard shoulder because people were using them as running lanes, nominally locals, to get to where they want to get to. And it's a horses for courses situation. But in Australia, there isn't an awful lot to take up on the news, to be perfectly honest. So it does get a big press when something does happen, accidents, interchanges, and various things. So I think people are aware of the technologies and things to help them, but there are other just basic elements. I may be so bold, the education of driving here is very, very different standards in different states, and some of that is a contributory factor. So smart motorways are something that people don't have in their vocabulary at the present time as much as it is in the UK.
You touched on driver education. Stephen, is that a defence for any criticisms? The more education that drivers are given, the more lessons they're given in how to drive on smart motorways. That and the other thing that was touched on, which was the stock vehicle detection technology. Are those things that then, when you're not even in a court of law, but just merely defending and explaining the concept of smart motorways, education and technology are two things that reassure, so to speak?
I think so. I mean, as you've touched on, I think the reporting of some of these things can paint the wrong picture. And it's not aided if you're getting coroners and police commissioners making quite stark comments. And then as the truth may be very different in terms of the statistics, and if smart motorways actually make up 20% of the network, then it may well be they're significantly safer than the overall network. So I think that possibly communication needs improving about their safety, that's certain. I think likewise driver education, there's clearly always room for improvement there, but you still can't get away from the fact that these accidents, the cause, often driver inattention, speeding, whatever it may be, there's a limit to what technology and infrastructure can offset. And it may well be that smart motorways are already improving on that, but I'm sure the further improvements are out there. Highways England probably do need to look at educating drivers more. I'm not sure why this particular motorist on the case that's causing the controversy over here didn't see over 16 minutes, and you would assume hundreds of vehicles passed the cars quite safely, yet this individual didn't and collided and caused those fatalities. I I think they probably, the safety measures are probably already there and improving. I think it's possibly how they're communicated to the public. You're still never going to get away from incidents where someone specifically could have avoided being killed if the conventional hard shoulder had been there. But yes, I think communication, personally, I don't think there's a legal issue for Highways England. I don't think that's going to be something that crops up personally. Yeah, from a litigation point of view, it will still be the fault lies with the other motorist that failed to stop speeding or inattention or whatever it may be.
And it's worth pointing out to viewers in Australia who may not know this, that the driver involved is actually in jail over the accident at the moment. So I'm just looking through some of the comments that are coming in. Max Brown says there's a perception that all fatalities on a smart motorway are related to live lane breakdowns, which is clearly not the case. As any road, there are all types of incidents, single vehicle when the driver falls asleep. So again, it's being able to take that step back and look at the statistics that and in the context of the statistics as well. And Danny Woolard has mentioned, again, stop vehicle detection. The delays in detection of stopped vehicles and response seems to be a major problem. It appears that there is a disconnect between the emergency services and the road operators. What do you consider could be done to improve this, particularly given the growth of connected vehicles? Of course, Highways England has said it's going to roll out the use of stop vehicle detection radar, and Paul talked about the safety features on motorways in Australia. But what more do you think we might be able to do?
I think from a technology perspective, there's been a lot of advancement in technologies over the last few years, particularly with Navtech. I know that some of the first rollouts weren't particularly covered in glory. And speaking with the Navtech guys, I see Brian Carpenter's on the call, but I also see that they had this unit which used to sit upside down, and by their own admission, it didn't work, and they've gone through quite an exhaustive period of developing that product to get to where it is today. And it certainly seems to be the sort of, I don't like using this to sound like a politician, but it's sort of coming towards the gold standard of device management that you can carry out the detection. So previously, if you had your Midas loops or your AID loops at every 500 meters, if you had an incident, it would take quite a while for you to be able to detect some flow breakdown upstream as a result of that. Whereas the radar is now typically, a few seconds, whether it's 5 seconds, 10 seconds, it's a magnitude of improvement, which is helping road operators considerably. And I think with the advent of connected and autonomous vehicles, connected vehicle data, use of data from companies like Google and Here, Waze and Uber and others, I think that's the next evolution for me, of seeing a larger sample size on the network being used to enhance network operations.
And Alex, I presume that the more data you have, the better the live assistance to traffic management becomes.
Totally, and I can confirm how critical is the incident detection. In most of our application, this is one of the major failure in having a useful or a prediction or a timely prediction is the time it takes to get the right information, the time about when the incident is communicated to the model, and also the information where people will say, well, I think it's 3 lanes, but in fact it's 1 lane that is blocked. So it's not only timely, but it's also the accuracy of what is happening that is important. So as Paul was saying, now we are very keen. We have the mathematical tools to be able to integrate way more data, especially if we can see the problem with different dimensions. Having multiple devices that tell you the same thing again and again, like flows or speed, is not really the solution. what you want to model a physical phenomena is to be observed by a lot of different angles, travel times, trajectories, flows, etc. There is Bluetooth additions now in a lot of transport network that allow us to track people and know where they are going, where people are entering in a certain ramp and exiting another ramp, that provide you some patterns of behavior that will allow you to understand how people are changing lanes. There is a lot of incidents that are related to the lane changing in these motorways, especially when on-ramps and off-ramps are very close to each other. So if we're able to understand these thanks to better data, we're also able to handle these on a better way in predicting what will happen, and also to assess what are possible solutions that will reduce the risk for accidents.
Okay, there are a couple of comments that are coming. One you might be interested in, which I think you've just explained why it didn't necessarily work. A system called Motorway Online Assistant was implemented in the English county of Kent in the 2000s, but fell into disrepute with the operators, as it usually told you to do nothing. But I guess the amount of data going into that, compared to the amount of data that we've got maybe 15 years later, is probably going to be the major difference. And just Daniel Johns has just asked, in your modeling, do you try to anticipate incidents? And if you do, how do you deal with it in your predictions and scenarios? Are you anticipating incidents, or are you anticipating the congestion that's caused either by large amounts of traffic on a road or by an incident that has happened?
Okay, so this is a very classic question that is being asked to transport models, is that do you predict incidents? Technically, the answer is no, it's not possible, for the simple reason that the simulation is based on behavioral models that are kind of basically having robot drivers. So they don't do mistake, they follow mathematical equations, is basically like automated vehicles. So the factor of the human failure is not included in the model by itself. However, the simulation is able to provide you a current status or some data, like I was just mentioning before. There is a huge number of lane changes that are happening between this ramp and this ramp. And we know that more lane changing you have, more chances of accident. So you can raise of saying, because we're doing this, we are minimizing the number of lane changing, for example, which will most probably decrease the risk of accident. But the problem we have is that we'll say, well, this situation has a chance of 1 of a million to have an accident today, while this one has a chance of 1 of 1,000 to have an accident today. It's still something that you cannot predict, because the number of trajectory that are close to accident but that don't end up in accidents are enormous compared to the number of accidents itself. Hope that makes sense.
Yeah, it does. So, right, we're sadly nearly out of time, because actually we could keep talking for a long time on this, but I'd like to thank the three of you. Paul, you've been fantastic, somebody who's worked on smart motorways on both sides of the planet and halfway across as well. Stephen, thank you very much for giving, I think, certainly the most sober and level-headed analysis of the situation on smart motorways from a legal point of view that I have heard anywhere at any point. So thank you ever so much for that. And Alex, for showing a glimpse of the future of stuff that you're doing that I think will be of massive interest to operators in the UK and in Australia, and not, of course, only on smart motorways. We've got a minute left each. I'd like you just to sum up what you've thought of the hour and some of the comments that you've heard. Paul, if we could start with you in Sydney.
Yeah, very quickly. I think as technologists and organisations supporting technology, I think the future is bright. But as Alex will attest to, and others on this call as well, I've been involved in integrating other transport data like Waze and HERE into situational awareness tools. And it is data isn't our issue. It's deriving intelligence from that data and being able to use it in a cognitive way, not providing cognitive overload for the operators. So operators are under a lot of stress, like air traffic controllers, and there's more expected from them. And when you're getting the sort of kind of press that is being pushed around at the moment, that doesn't help them in terms of the way that they approach their job. And they see a lot of things on those cameras that you wouldn't want to see. So I think in the future, the use of this technology and data should significantly help them, and those people are going to help, drive outcomes on the network. And I know, Tony Earl's been a big supporter of that, and made a lot of changes in the way that the network operations runs in Perth for the smart freeways and other aspects of his business.
Thank you very much. Stephen, as I say, a very sober, level-headed view on smart motorways. What's your recommendation from sort of outside the ITS sector looking in for people tasked with implementing and then operating this technology?
I think it boils down to a communication. I think that the fairly histrionic press reaction to one-off incidents is unhelpful. And I think it boils, I think it's the perception over reality. I think that from today, I found today very useful. I think that the reality is that these systems are working and improving safety. There's things that can still be done. You're still going to have the difficulty that you get bad motorists. So I think ultimately, possibly the communication to get that out, the message out there that this is much safer or is safer, and what more can be done. And that driver behaviour is still a factor that needs improvement. So it's you can't blame the roads and the infrastructure, which is improving. So I think just get a simple message across from the likes of Highways England that these are safer or improving, but we will still unfortunately have incidents of fatalities, and not necessarily, I think, linked just to the absence of a hard shoulder, which when you analyse one individual case can make it seem that there's sort of inherent lack of safety within these networks.
Right, and Alex, if you'd like to just wrap up with your thoughts on what we've heard in the hour, thank you very much.
No problem. Well, to the risk of repeating what Paul just said, I totally agree that the main concern here is not about getting the data, is to make a good use of them. The same with the technology. Now we have amazing things out there. We have people coming and saying, I have gigas and gigas of data. You can do magic out of it. Well, yeah, but it's not just in throwing this into a computer and having just like a machine learning process. You have to get to the essence, and especially not forget that still for a while, we will have human behavior in all these. So we shouldn't forget this aspect on the way we are working. It's not just about data. Data are very useful, but let's go back to sometimes the basics. Humans are driving these vehicles, and we have to consider this in our solutions.
So thank you very much to Alex Torday, Stephen Bayliss and Paul Glover for their excellent conversation and insight in the last hour. Thank you for staying up and working late in Australia, or for getting up early and starting work early in the UK. We're going to be doing another one of these between ITS Australia and ITS UK on the 10th of March, again, 8 o'clock in the morning in the UK and 7 p.m. in Sydney and Melbourne, with the subject active travel, and Susan Harris will be hosting that, CEO of ITS Australia, and we'll be comparing and contrasting some of the ideas and solutions that each country has come up with and where technology fits in. Thank you ever so much for watching, and have a good evening or a good day, and we'll join you again on the 10th of March. Thank you.